Hello everyone, welcome to my data science and AI channel Analytics Yogi. My name is Ajitesh and I'm here to bring you the tutorials on machine learning and data science, latest insights and innovation in the field of data science and AI. In this video, we are going to dive into regression model performance metrics concepts including MSE, RMSE, MAE, MAPE, R squared, and adjusted R squared. So whether you're a beginner looking to understand the basics or someone looking to brush up on concepts, you've come to the right place. Before going further, I would urge you to subscribe to my channel for more such informative videos in future. Alright, so let's get started. The first metrics that we are going to learn is MSE. It's a short for mean squared error. Mean squared error can be understood as the cost function used for the regression models. MSE is used to calculate the average squared difference between the model's predicted value and the actual value. Lesser the MSE, better is the performance of the regression model. So when we are comparing the two regression models, we can use MSE to compare their performance. MSE emphasizes the larger errors owing to the square term. So if we have a need to assess the variability of the error in terms of how large it is recommended that we use MSE as the performance metrics. Now that we have learned about MSE, let's look at a closely related metrics, which is RMSE. It is a short for root mean squared error. RMSE, as you're seeing in the formula here, is calculated as a square root of MSE. So as you're seeing in the formula, you have the actual value, which is yi, and the model predicted value, which is y hat. Now for each of the record, we go and take the square and sum it up, and finally we go and average it out with the total number of records and then take a square root. This is calculated as RMSE. RMSE is a great metric because it is at the same scale as the target variable. So if we are out there to predict the house prices, when we calculate the RMSE, we get the output in terms of house prices. If our house is say $100,000 and if the model predicted value is say $130,000, and now if we have to find an RMSE of it, it will be actually $30,000. So this helps in greater interpretability of the error. Now let's look at another concept, which is MAE. MAE is another metric which is used to assess the performance of the regression models. MAE stands for mean absolute error. It can be understood as the cost function, whose output is basically an average of the absolute difference between the model predicted value and the actual values for the entire record. And if you look at the formula, you'll see that we have the actual output value subtracted by the model predicted output value, and then for each record we take the absolute value of it and then sum it up and finally go and average the summed value, which actually gives the value of MAE. Why do we use MAE? MAE provides the greater interpretability of the loss or the error as like RMSE. And the reason why we use is if we really want to avoid the penalties due to larger errors as it happens in case of the MSE, MAE is one of the useful metric for that purpose. Now let's take a look at another metric, MAPE. MAPE or MAPE, this stands for mean absolute percentage error. Now this is a cost function which calculates the error as the difference between the model predicted and the actual value as a percentage of actual value. So for example, if the actual cost of the house is $200,000 and if the model predicted value is $180,000, then MAPE comes out to be $200,000 minus $180,000 upon $200,000 into 100, and that actually gives you an error of 10%. Now this is very useful for those who are non-technical stakeholders. It helps in greater interpretability for them in terms of the percentage. Unlike RMSE or MAE, this basically is a scale independent view of the error. So as you are seeing in the formula, we have the actual value minus the predicted value, which is depicted by y hat, upon the actual value, which is y, and then this is averaged out with the total number of records, and that makes it mean, and then when we multiply it with 100, it becomes mean absolute percentage error. Now let's look at another metric, which is R squared. R squared is another popular metrics for the regression model performance assessment. It can be represented as the proportion of variance in the dependent variable that can be explained by the independent variables based on the predictions. The value of R squared ranges from 0 to 1, with the value closer to 1 representing that the regression model has a good performance. If you take a look at this formula, it is 1 minus the sum of squared residual error upon the sum of squared total, and I'll explain this in the next slide based on the diagram. R squared offers a scale independent view of the error as like MAPE. It enables the ease of model comparison. Now let's understand how R squared represents a proportion of the variance of the dependent variable in terms of the independent variables. So if you see from each of the point to the horizontal line, which is basically the mean of all of the value of the target variable, this difference, when we take sum of squared, it can be called as sum of squared total. And the difference between the point on the regression line and this mean line, this is called as the sum of squared regression. So R squared can be represented as the ratio of sum of squared regression and the sum of squared total, or it can also be represented as 1 minus the ratio of sum of squared residual errors and the sum of squared total. So this is what is the concept of R squared. One of the disadvantage of R squared is, as we continue to add on the independent variables, also called as predictive variables, the value of R squared continues to increase irrespective of the fact that the new independent variable is really good for the regression model performance. Now this aspect is addressed by having another matrix which is called adjusted R squared. Let's go and take a look at that metric. Adjusted R squared addresses the limitation of R squared where adding an independent variable or a predictive variable increases the value of R squared. In case of adjusted R squared, the value increases only if the added predictive variable improves the model performance. So from that perspective, adjusted R squared can be seen as more reliable metric than the R squared. As like R squared, it also offers a scale independent view of the error and enables the ease of model comparison. If you take a look at this formula, it actually tells how adjusted R squared can be a function of R squared. Alright, so that's all I had to talk in this video. Hope you like this video. If you have any questions regarding any of the metric, I would urge you to write in the comment box and I would address them appropriately. Thank you very much for watching this video. Have a nice day.